In order to illustrate the application of center of gravity method, let us consider a practical situation which has been solved in supply chain simulation and optimization software, anyLogistix. We consider a brewery which is located in Germany, and this brewery has about 50 customers across different European countries. The question, decision-making situation for supply chain manager of this brewery is now to decide where to locate a warehouse from which all these customers will be served. And another question is, should it be a one warehouse, so a single warehouse, or maybe two, or maybe several warehouses? And here we can use the methodology of center of gravity method to answer these questions. Software supports us in this computation. Now we can see how the center of gravity models can be implemented in practice. For example, we have these 50 customers, and we are given their locations, which are designated by two coordinates, as in center of gravity method. For each customer location, we always need two coordinates. And so each of our 50 customers is designated this coordinate. Second, in order to run center of gravity method, we need demand information. Right? Again, for each customer, we are given demand quantity. And this is actually now all data what we need in order to run center of gravity experiment and to help supply chain manager to determine optimal warehouse location or locations, if many. So we first run the experiment for situation where our supply chain manager is looking for only one single location. So, and now we can see that we have a solution. If we look at the map, on the map, we can see that the software found optimal solution for a single warehouse in this network. We can take a closer look where this distribution center would be located, right? So by locating distribution center exactly in this point, we would ensure the total minimum cost in the supply chain. Here we can look at the total cost computation. Yes, in that case, our total supply chain cost would be 139,759,720 euro. With the same data, our supply chain manager can also run an experiment where, for example, 5 facility locations should be found. And then we can also anticipate what would happen with our total transportation cost. As we know from theory, if we increase the number of warehouses, the transportation cost should be decreased. Let us check. We found now optimal 5 locations, right? And interestingly, we can also see that our total cost has been reduced. So in other words, the theoretical concepts have been confirmed. We could, with redesigning of our supply chain from 1 warehouse to 5 warehouses, we could reduce transportation costs from 140 million or 139 million to 58 million. This is a huge saving in the transportation area of the supply chain. So here we can see how to apply center of gravity method in practice. And also here we can see interesting observation in terms of cost saving if we increase the number of warehouses. We can also use this analysis for comparing efficient and responsive supply chain strategies, right? Because of course, if you open more distribution centers, you are more responsive. and you're actually also more efficient in terms of transportation cost. However, in center of gravity method, we have not considered fixed warehousing cost and inventory holding cost. Right? And as such, our analysis for the total supply chain should be extended. Usually we do it through network optimization, where we analyze different possible costs, such as, for example, inventory holding cost and facility fixed cost. If we would include this analysis into consideration, all these costs, right, then when running network optimization experiment, we could see that, for example, if the supply chain with one distribution center and one factory, it's actually the most profitable, right? This also confirms theoretical concept that on one hand, with simplifying supply chain structure with having single sourcing strategy, we can improve efficiency. However, it can have negative impact on our responsiveness. All right, it is such responsiveness that also resilience to possible disruptions. That's why maybe supply chain design, which would have two distribution centers, right, and one factory would be more resilient, right? Since if something happens, for example, in one distribution center, the second distribution center would keep operations continuity, and so ensure some risk resistance of the supply chain. And you can see the difference in profit in this particular case between single source supply chain and dual source supply chain with 2DC. It's quite low, but we get a lot of advantages in terms of responsiveness and agility and resilience. We can just run a quick simulation to confirm it. For example, we consider first situation where we don't have second distribution center, right? Where we have only one distribution center in Berlin. And here, if we run a simulation, we can see that, we have huge impact of disruption. Our service level on time delivery is reduced. And so I consider here situation where distribution center in Berlin experienced a disruption for 2 months. It was closed, for example, due to some lockdown measures, quarantine measures during the COVID-19 pandemic time. And we can see impact of this disruption for 2 months, both for inventory performance and for customer performance. And now we can also see that in such situation, we would make a profit of 8 million euro. Right? And if we run the same experiment now with 2 distribution centers, right, in Spain and in Berlin, we could see that the second backup DC would have a very positive effect on the resilience. So we have only a very small, really small impact on the service level, and our inventory dynamics, it's not interrupted. And in this case, we can make profit of 10 million. So 8 in case of 1 DC and 10 in case of 2 DCs, right? So 25% more profit. This confirms positive impact of backup resilience strategy on supply chain performance. So far, we have discussed some implications which you can obtain when utilizing supply chain methodology and implementing it in software regarding efficiency, responsiveness, and resilience.